Hello friends, you are welcome to my series Embedded Design in Electrical Power Domain, and this is the part 7 of the series. What we have done so far? What we have done is we have identified 3 distinct areas for embedded design in electrical power area. What are the 3? Monitor, control and protect. If you want to control or if you want to protect, then you must know how to monitor, because without monitoring you can neither control nor you can protect. That's why in the first few parts we have handled the monitor aspect of it. What do you monitor? You monitor voltage, you monitor current, you monitor power factor, you monitor so many different things, and we have covered them all in the monitor section of this series. Now we are going to go into control. In control, I'm going to take up this product, which is power factor controller. I will take up this power factor controller. Why do you want to control power factor? We will see that too. We'll see. You know that active power is VI cos phi, and therefore if K is equal to active power upon V, if K is equal to active power upon V, then I will be equal to K upon cos phi. This is quite clear. What does this mean? What is the use of this statement? Now, if cos phi is small, for a given K, I will be very high. What is K? It is the active power upon voltage, and you suppose want to use 100 kilowatts and voltage is constant at 400, then K will be constant, and for a given K, there will be more current if cos phi is less. When you exceed current above a reasonable value, that is above the optimum value, then you are really unnecessarily loading the power supply company transformer. And that's why the power supply company says, no, you must reduce your current, and for that you must increase the cos phi. So that is where the cos phi comes into picture. The power factor controller comes into picture. Otherwise, you have to pay heavy penalty to the power supply company. So power supply company checks your cos phi, and if they find it is poor, they immediately apply a penalty. So not only to avoid penalty, but also to be more sensible in utilization of energy, you should keep I as low as possible without affecting K, without affecting any of these parameters, V and active power. So you draw the power you want, but keep the current as low as possible. For that, you have to keep cos phi as high as possible, and the highest value of cos phi is 1. So friends, you need to do this power factor controlling. In one simple case I have shown, there is a voltage you are receiving, and this is the load you are having. This is the load current, I load. And the power factor is based on phi 1. So cos phi 1 is the power factor in this case. And the current, you can see, is from here to here. Now when I improve the power factor, how can I improve power factor? I connect a capacitor on my line. So at the point where connection or electricity enters your premises, that is where you connect capacitor. If you connect the capacitor, then capacitor current is leading. This current is lagging as well as resistive. So you try to neutralize the inductive current of the load by capacitive current. I have shown the ideal case where this is perfectly vertical, but normally it will be slightly inclined because a capacitor unit also has got some limitations. So friends, what you see is, if I have this much current and if I add this current, then the resulting current will be this vector plus this factor produces this current, which is I res, that as mentioned, which means that the power factor reduces from phi1 to phi2. And you also notice that the current also reduces. So from this length, it has come down to this length. Or if you look at the vertical component, it was so much. Now it has become just this much. Where from this come? Why it has moved from here to here? From up to this point, from here. Because you have added this. So this current has effectively gone up and you have reached this. So in the case of a power factor controller, what you are expected to do? You are expected to measure power factor, and if it is below 1, then you must keep adding capacitors. That is the basic purpose of a power factor controller. So how will you measure power factor? You have already done it. That's what you did in the monitor section of this series. Let us have a look. In the last episode, you had done 4 things out of this. Power factor is 1. And what is power factor? Active power upon apparent power. You already measured. Right? Remember, you measured this. If you don't remember this, take a look at this. This is what you did for apparent power, power factor, reactive power, and frequency. So we are interested in only finding the power factor. So for measuring that, you pick up voltage, you pick up current, and go through this, develop this, and you already seen the power factor, how it is obtained, right? So we are going to do this, and to do this, we need something more. This is a power factor controller. So this power factor controller, as you can see, it is using this microcontroller to measure current and voltage, and you are absolutely totally familiar with how to do it. Then what will it do? If it finds that the power factor is less than unity, then it will connect capacitors. How will you connect capacitors? See, you can see this. This is RYBN. This is the power entering your premises, and you have a group of capacitors here, one set. So for every phase, you have one capacitor. So you have capacitors like this. So one goes to R, one goes to Y, the other goes to V. This is neutral, it returns here. So if you switch on this is the relay driver, and this is the relay. So if this relay operates, then these 3 switches will close. As a result, RYB will get these 3 capacitors. Done? And then you measure, you keep measuring. So you find that no, the power factor is still much below 1. Then what to do? So you will say, okay, I will switch on another capacitor bank. So you will switch on this capacitor bank by closing these 3 switches. So the capacitor draws current from the same 3-phase line and provides a capacitive current, which reduces the power, which increases the power factor. And if you find that no, it is not yet enough, I should add more capacitors, then you switch on the 3rd relay also, and then these 3 capacitors will be connected. I have given an example of only 3 capacitor banks, but you may have a still larger number of capacitor banks. It all depends on how you look at the requirement of the customer. So I have shown only 3 stages, 1, 2, and 3 stages. So there are 3 LEDs. So when one stage is turned on, this LED will glow. Here I have shown that all the 3 have been turned on, although this fact does not reflect here, because this is how I say I will be able to explain how the operation. Now you also see what is the power factor. So you have a 7-segment display with 3 digits, and you can show the power factor. So these 3 LEDs need a LED driver, and this requires 9 lines. Why? Because 7 segments each plus 2 digits. This is always 1. This LED is always 1, means glowing. So the 0 is always low because the power factor can never exceed 1. So you may ask why it is not 1. We don't allow a unity power factor because it can quickly swing into the leading, and leading current is not recommended because it has several unacceptable consequences. So what we have done is we have measured the power factor, and when we see that it is below 1, then we try to connect one capacitor bank. If you find that it is still below 1, then try another. Still below 1, try another. In this way, we keep adding capacitors. I have shown 3 stages, but you can have n number of stages, and the concept is same, no change. Friends, this is how a power factor correction relay works, and you have noticed that to be able to do this, you needed to measure power factor. So, and you already have learned how to do it. So friends, I hope you have fully grasped the power factor controller concept, and there's a relay driver you already know. It is an IC, and this is simple IC, 2000 series or something like that. Here also you have some transistors to drive these LEDs, and here you have a 7-segment display with 3 digits. If you want, you can make it even 1. With the 2 extra lines, you could go for 4 possibilities. So you could do this also. So you can even show power factor as 1.00 if it so happens. There is no harm in doing it. In this case, I have not done that. So friends, we will move in the next episode into protection, right? So until then, enjoy, try to understand, try to learn how to optimally utilize whatever resources you have. See you in the next episode. Thank you.